On page 255, problem number 127, we have a limiting reactant problem, and I've modified it a little bit to make it also a percent yield. We have the following equation, which I've already balanced, which is aluminum plus oxygen gives me aluminum oxide, and we have 4 aluminums plus 3 oxygens give me 2 aluminum oxide. So we've already balanced the equation. And so we look down here and we see that we have the problem 13.5 grams of aluminum reacts with 8 grams of oxygen. How many grams of aluminum oxide can you form? If you actually obtain 5.9 grams of aluminum oxide, what was the percent yield? Okay? So when we do a limiting reactant problem, we have to decide how much we have of one of the reactants versus how much we need of that reactant. And so I like to work from top to bottom and left to right, so we'll start with the 13.5 grams of aluminum oxide, and we'll use that to determine how many grams of oxygen that we need. So we've got 13.9 grams of aluminum, and a mole of aluminum is 27.0 grams. And then we need the mole ratio of the oxygen to the aluminum, which is 3 oxygens for every 4 aluminums. We pull that right off the balanced equation, and we plug that into our calculator, and we get 13.9 times 3 divided by parentheses 27 times 4, close parentheses, equals, and I get 0.386 mole oxygen that we need. Now we need to know how many moles oxygen we have, and we have 8.0 grams of oxygen, and it is 32.0 grams per mole. Remember, we got oxygen. Oxygen is O2. It's not just one oxygen, it's 2 oxygens, and that'll give us however many moles oxygen that we have, and that is 8 divided by 32, and as 0.25 moles oxygen that we have. We have 0.25 moles of oxygen, and we need 0.386 moles of oxygen to react with 13.9 grams of aluminum, so therefore oxygen is limiting. O2 is limit. But we've determined that oxygen is limiting, we can go ahead and calculate how many grams of aluminum oxide we'll get, and so we always use whatever we determine to be limiting. So oxygen is limiting, so we go 0.25 moles of oxygen. We need the mole ratio of aluminum oxide to oxygen, so that's 2 aluminum oxides for every 3 oxygens. And then finally, it's 102 grams per mole of aluminum oxide, and we're done with that part. And so we have 0.25 times 2 times 102 divided by 3, and that gives me 17 grams of aluminum oxide. And then finally we need the percent yield, and percent yield is actual over theoretical. Theoretical at this point is 17 grams, and we actually got 5.9 grams. So 5.9 grams divided by what we determined theoretically times 100 gives me my percent yield, and so that is 5.9 divided by 17 times 100, and I get 34.7% yield.